We now discuss the solution of a problem from the section Integral Calculus. The problem is related to a definite integral involving greatest integer function. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is the integral 0 to 1 by, in the denominator, 7 to the power of bracket 1 by x dx, where bracket denotes the greatest integer function is equal to. So we have to evaluate this definite integral 0 to 1 by 7 to the power of bracket 1 by x with respect to x, where bracket is the greatest integer function. We are given four options. Option A, 1 plus 6 log 6 by 7 to the base e. Option B, 1 minus 6 log 6 by 7 to the base e. Option C, log 7 by 6 to the base e. Option D, 1 minus 7 times log 6 by 7 to the base e. That is the given question to us. Let's now discuss the solution of the problem in detail. We put 1 by x is equal to t. Differentiating, we'll get minus 1 by x square dx is equal to dt. Then dx is equal to minus x square dt, but x is 1 by t, so it will be equal to dx is equal to minus 1 by t square dt. Agreed. Now take the integral. Now because this is a definite integral, what happens to the limits? Now when x is equal to 0 will imply t tends to infinity. 1 by 0 tends to infinity. When x is equal to 1, t is 1. Then the given definite integral 0 to 1 by 7 to the power of bracket 1 by x dx is equal to, the transformed integral is integral 0 to 1 means infinity to 1. Dx we have written minus 1 by t square dt, minus 1 by t square dt into 1 by 7 to the power of bracket t, because bracket 1 by x is t, bracket t. And now this minus is taken care of. We have changed the limits. Infinity to 1 we have written as 1 to infinity, that minus will go off. Integral 1 to infinity 1 by t square 1 by 7 to the power of bracket t dt. Now we will break this integral. Integral 1 to 2, 2 to 3, 3 to 4 and so on and so forth. And that is equal to integral 1 to 2. The function is same. Plus integral 2 to 3 plus integral 3 to 4, so on and so forth. Now in the interval 1 to 2, bracket t is a lower one, that is 1. So it will be 7 to the power of 1. In the interval 2 to 3, bracket t is 2, it is 7 square. In the interval 3 to 4, bracket t is 3, it is 1 by 7 cube. So that's what we have 1 by 7 square, 1 by 7 cube, so on and so forth. Now these constants 1 by 7 square, 1 by 7 cube, we will take out. 1 by 7 into integral 1 to 2 1 by t square dt plus 1 by 7 square integral 2 to 3 1 by t square dt plus 1 by 7 cube integral 3 to 4 1 by t square dt. Now the integral of 1 by t square is minus 1 by t in all these things, and put the appropriate limits. And that is equal to 1 by 7 minus 1 by t 1 to 2 plus 1 by 7 square minus 1 by t 2 to 3 plus 1 by 7 cube minus 1 by t to be evaluated between the limits 3 to 4 plus so on and so forth. Now when you evaluate minus 1 by t, it will be 1 by the lower limit 1 by 1 minus 1 by the upper limit 2. We have taken care of this minus. So lower minus upper we will do because of the minus. So that is equal to 1 by 7, 1 by 1 minus 1 by 2 plus 1 by 7 square, 1 by 2 minus 1 by 3 plus 1 by 7 cube, 1 by 3 minus 1 by 4 plus so on and so forth. We continue in the next slide. So that's what we have done so far. Now collect all positive terms, that is 1 by 7 plus 1 by 7 square into 1 by 2 plus 1 by 7 cube into 1 by 3 so on and so forth. Collect the positive terms. Right. Then collect all the negative terms and put a minus sign before that, and minus in brackets 1 by 2 into 1 by 7 plus 1 by 3 into 1 by 7 square plus 1 by 4 into 1 by 7 cube. So that's what we have written. Now recall, this is very familiar expansion. So recall log of 1 minus x to the base e, and we have the Maclaurin's expansion, that is minus x square by 2 minus x cube by 3 minus so on and so forth, valid in minus 1 less than or equal to x less than 1. Yes. And in this, put x is equal to 1 by 7. Then you will get log of 1 minus 1 by 7 to the base e is equal to minus 1 by 7 minus 1 by 2 into 1 by 7 square minus 1 by 3 into 1 by 7 cube minus so on and so forth. But we have all positive terms. Therefore 1 by 7 plus 1 by 2 into 1 by 7 square plus 1 by 3 into 1 by 7 cube plus so on and so forth is minus log of 6 by 7 to the base e. Go back and substitute for this log of minus log of 6 by 7. Now look at this one, and it's also looking something related to logarithm of 1 minus x only. So we multiply and divide by 7. So I'll write minus 7 into 1 by 2 into 1 by 7 becomes 1 by 7 square plus 1 by 3 into 1 by 7 cube plus 1 by 4 into 1 by 7 to the power of 4. So this is what? This is a truncated portion of this logarithm. What is this one? In this the bracket, what is written in the bracket is same as this except for 1 by 7. So from this we write, so the first term is as it is. For the second one, we come here and see 1 by 2 into 1 by 7 square plus 1 by 3 into 1 by 7 cube plus so on and so forth is minus log of 6 by 7 to the base e minus 1 by 7. So minus 7 into this one you substitute for the bracket one. So minus 7 into minus of log of 6 by 7 minus 1 by 7. Take the minus inside, then you will get minus log of 6 by 7 to the base e plus 7 times log of 6 by 7 to the base e minus 7 plus 7 into 1 by 7 is plus 1. So it is 1 plus 6 log of 6 by 7 to the base e. That is your answer. And let's look at our options. Our answer appears against option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of the problem which is related to the definite integral involving greatest integer function. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.